Hi everyone, in this video I want to show you how we can get an equation for a polynomial if all we know is the roots or the x-intercepts. So the main tool that we're using here is that if b is a root, so in other words when I plug b into my equation I get 0, that's the same as saying that x minus b is a factor. That's also the same as saying that b comma 0 is an x-intercept. So our goal is going to be to use these relationships in order to come up with an equation for a polynomial. And we'll do it by building up the factors. So let's see an example. So here's a graph of a polynomial. And I want to write the equation of this polynomial in this form. F of x equals x minus b times x minus c times x minus d, and so on, and some scaling factor. So how do I get these factors? Well, I know that if b comma 0 is an x-intercept, then x minus b is a factor. So I look at my x-intercepts. I've got 1 at 2 and 1 at negative 1. So the x-intercepts are 2 comma 0 and negative 1 comma 0. What this tells me is that my polynomial will have factors x minus 2 and x minus negative 1, which is the same as x plus 1. And then I have a scaling factor. There's one important thing that I'm missing, and that is whenever I have an x-intercept and the graph just barely kisses it rather than going through, that means that the factor corresponding to it, so this x minus 2 factor, is raised to the power 2, or some other even power, but in our case, it's raised to the power of 2. I know that because, well, I should have told you that this is a cubic. So when I multiply the whole thing out, the biggest power of x should be 3. Okay, so now in order to finish this equation, I need to find a. So to do that, I choose another point on my graph and plug it in for x and y so that I can solve for a. So a good point to choose is the y-intercept if I can. So since 0, 1 is on my graph, that means that f of 0 equals 1. When I plug in 0, I get out 1. So I'll just plug 0 in for x and 1 in for f of x and solve for a. If 1 equals a times 0 minus 2 squared times 0 plus 1. And now I solve for a. So 1 equals 0 minus 2 squared is 4 times 4. 0 plus 1 is just 1, so that's times 1. This tells me that a equals 1 over 4, because I'll divide both sides by 4 to isolate a. And now I will just plug this in to my equation. So I have f of x equals 1 over 4 times x minus 2 squared times x plus 1. So I build up my equation by using the roots to tell me what the factors are, and then finding this scaling factor by just plugging in a point and solving for it. So let's do another example. In this first example, we used the fact that b0 being an x-intercept means x minus b is a factor. In the second example, we'll use this part of it, that if b is a root, then x minus b is a factor. So in this example, I'm given that my roots are 0, 2, and negative 1. And I guess I should tell you again, this will be a cubic polynomial, so I should have degree 3. So I'm going to do the same thing. I'm going to build up my polynomial by first figuring out what the factors are, and then plugging in a point to figure out what that scaling value a is. So I'm looking to get a function that looks like a times x minus b times x minus c times x minus d. So here are the factors, and this is the scaling factor. Now the key here is that if b is a root, x minus b is a factor. So since 0 is a root, x minus 0 is a factor. Since 2 is a root, x minus 2 is a factor. Since 1 is a root, x minus -1 is a factor. So x plus 1 is a factor. So my polynomial is made up of all of these factors. And it's scaled by a. And again, I need to solve for a. In the last example, I did that by looking at a point on my graph, which happened to be the y-intercept, and plugging the x-coordinate in for x and the y-coordinate of that point in for y. So I'm going to do that again, but in this example I'm given f of 3 equals 6 instead of being given f of 0 equals 1. So to figure out my scaling factor, I'll use this. So f of 3 just means plug 3 in for x. So I have 3 minus 0, 3 minus 2, and 3 plus 1. And since when I plug in 3 for x, I'm supposed to get 6, I set this equal to 6. And now I solve for a. So a times 3, 3 minus 2 is 1, times 1, 3 plus 1 is 4. So 6 equals 12 times a. So divide both sides by 12, and I find that a equals 1/2. So I'm not done. I have to go ahead and plug this back into my equation to get my final answer. So f of x equals 1/2 x minus 0, x minus 2 times x plus 1. Sorry, got a little cut off there. So this is the strategy for building up equations for polynomials just by knowing either the roots or the x-intercepts. And it all comes down to essentially the factor theorem, that if b is a root, x minus b is a factor, and that's the same as b0 being an x-intercept. So I hope this helps. Good luck with the problems.